Problem number 2 here in lesson 7. We're visiting the state park. Entrance to a state park costs $6 plus $2 for each person that you have in the vehicle. Now, unless you're hiding people in the trunk, you got to pay for everybody that's in the vehicle and $6 for the vehicle. So we got a table here to help us with that and fill out this information to the side. So just do some quick math here. If we got 2 people in the vehicle, we got to pay $6 plus $2 for each of those 2 people, which would be 4. 4 plus 6, this would cost us $10. If we had 4 people in the vehicle, we got to pay the $6 no matter what, plus $2 for each. That's 8 plus the 6, $14. And then for this next one, we've got 10 people. I guess we're driving a large van of some sort. To be able to squeeze 10 people in there, but that's $2 each. That's $20 for the 10 people, plus the $6 for the vehicle. That one is $26. So we've filled out the table. We've done number 1, how much it would cost for all those. For each row in the table, if each person in the vehicle splits the entrance cost equally, how much would each person pay? So this is how much the whole vehicle has to pay total. We're going to set up another column here. What is the price that each person pays? Let's say we were going to equally split it up amongst everybody that's in the car. So that means we're just going to take the total and divide it by the number of people that are in the vehicle. So, $10 divided amongst 2 people, we're paying $5 each. $14 divided by 4. Might have to do a little work for that. 14 divided by 4. We'll go into it 3 times with 2 left over. So that's 3 2/4, which is 3 1/2, so $3.50. And then 26 divided by 10. That's easy enough. That's just a decimal move to the left. So that would be $2.60. Let's put the 0 on there so we know we're talking about money here. And that's how much each person would equally pay for the trip into the park with that many people. So the more people you get in the vehicle, the less amount it costs for each person. That's kind of going down. How might you determine the entrance cost for a bus with 50 people in it? Well, I guess we could just add that to our table. If we had 50 people, then $2 each, that's $100, plus the 6 for the bus, it's $106. And technically, if you split that amongst everybody on the bus, all you'd have to do is 106 divided by 50. And if you did 106 divided by 50, you would get the price that each person would pay, $2.12. So that's $2.12. Is the relationship between the number of people, this column, and the total entrance cost a proportional relationship? Explain how you know. Well, if it's a proportional relationship, we should have, between these 2 columns right here, we're ignoring this column for now, then these 2 should be able to find a constant and work for all of the numbers. Well, if we do that, 10 divided by 2 is 5. That's simple enough, right? We multiply by 5. But the question is, does that work for every example in the table? And it doesn't. 4 times 5 is not 14. So this is not a proportional relationship. Not proportional, and I know it because it's not proportional because there is no constant of proportionality. There's no constant relationship between all of the columns pairs. Okay, I can't multiply by 5 every time and it works, so it's not proportional. All of these ratios, 10 to 2, 14 to 4, 26 to 10, yada, 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 they are not proportional because they don't have the equivalent value. 10 divided by 2, 14 divided by 4, they don't all equal the same thing, so it's not a proportional relationship. And then down here at the bottom, a little extra, what equation could you use to find the total entrance cost for a vehicle with any number of people? There is a relationship between these, and what we did